Hi guys, today we're doing Introduction to Matrices. What is a matrix? So a matrix is a rectangular arrangement of numbers in rows and columns. Notice that the order matters. We're going to talk a little bit more about this in a minute. So the numbers in a matrix are called the elements. So here we have some elements of the matrix. So the number of rows, horizontal. So on this one, it's row number 1, row number 2, row number 3. And then the number of columns, they're the vertical. So column number 1, column number 2. Determine the dimensions of the matrix. The dimensions of a matrix are always written in rows and then the columns. So that's why I said the rows and columns, the order matters. So what are the dimensions of these three matrices? Well, how many rows do we have here? We have 1, 2, 3 rows by how many columns? 1, 2. Okay, how about number 2? We have 2 rows by 1, 2, 3 columns. And example number 3, we have 2 rows and 2 columns. So two matrices are equal only if they have the same dimensions. So this and this, they're not the same matrix because notice that the number of rows are different than the number of rows are different and the number of columns are different. Okay? So we can find each value of the variable by knowing that if this, let me find a highlighter. So this x equals that -9. So if they're sitting in the same position, that's where they're equivalent, they're the same. So x equals -9. Notice how 3 equals 3 right there. So y is right there. So y equals -2. Y equals -2. And then we have z equals -6. So z equals -6. Okay, we're going to get a little crazy right here. Not too much though, because we already know that their positions will mean that they're equal. So this equals that. So x plus 9 equals 7, minus 9 on both sides. That means x is -2. 3 equals 3. Now, the next one, haha. So we know this equals that just because they're in the same position. So set it up. 2x minus y equals 1. We already know x equals -2. So go ahead and substitute that value for x. So 2 is -2 times x, which is -2, minus y equals 1. Here I have -4 minus y equals 1. Add 4 to both sides. That will give you 5 right there. Divide both sides by -1. Y equals -5. So if two matrices have the same dimensions, that means same number of rows by same number of columns, then they may be added by finding the sums of the corresponding elements. So right here, we can find A plus B. That means add matrix A with matrix B. That's what it's asking us to do. The way we're going to do that, we're going to add by position. So let's say we're going to add position 1 right there, 1, 1. And we will learn about their position in a minute. So 1 plus 3 is 4. Then you go 3 plus 1 is 4. That's from over here. And then we have -2 minus 5 is negative 7. So this is the pink one. And so on. So 4 and 0 is 4, 0, and negative 7 is negative 7, negative 5 plus 2 is negative 3. So voila. Notice that if you weren't listening, this answer means nothing to you. So all we did was we added the same positions to get the answer for matrix A added to matrix B. And we can do more with it. We can do subtractions also, imagine that. And we're going to follow the same idea. So A minus B, so we're going to do 1 minus 3. That's negative 2. 3 minus 1 is 2. Negative 2 minus negative 5. Be careful with that. So we're doing negative 2 minus negative 5. So here, two negatives make a positive. So in reality, you're doing negative 2 plus 5 right there because of the negative, because you're subtracting B. You're subtracting the B matrix. So this will give you a 3. Okay, so 4 minus 0 is 4. 0 minus negative 7. Two negatives make a positive, so positive 7. Negative 5 minus 2, that's negative 7. Now, wait a minute. If I need to add by position, when you look at matrix A or number 8, it is 2 rows by 3 columns. In this one, it's 2 rows by 2 rows. If they don't have the same dimension, I cannot add them or subtract them. It doesn't work that way. Okay? So you can just write NP or not possible because the dimensions are different. Okay. So in matrix algebra, a real number is called scalar. What does that mean? That's that number right there in the front. So, and you can multiply a matrix by a scalar number or a whole number or by a fraction. We will get there soon. So it is easier than you think. So we multiply each one of those elements by the scalar or by negative 2. So negative 2 times 1, negative 2, negative 2 times 3, negative 6, and so on. Negative 2 times 3 again, and then negative 2 times 4, negative 8. That's all you're doing. Now the next one, we added a couple more steps on this. So we're going to do by parts. I will multiply this first, and then I'll multiply this first, and then we put them together. So off we go. So multiply every element right here by 2. So now I will go ahead and multiply everybody by negative 3 instead of multiply by 3 and then subtract. That's harder. In my eyes, it's easier to add than it is to subtract. So multiply everybody by negative 3 right here. That's why I put a plus right there. So negative 3 times negative 1 is 3. Negative 3 times 4 is negative 12. Negative 3 times 0, negative 3 times 2. Okay? Now we can just happily add them. So 2 plus 3 is 5. 6 minus 12 is negative 6. 18 plus 0 is 18. 8 minus 6 is 2. Voila. Do we have time for one more? Okay. So now, the next one, I will add them first. Notice that they have the same dimensions. And then I'll multiply whatever I get by 4. So I'm going to leave that 4 right there. And then I'll add them. So 3 and 6, -1 and 8, 9, -1, -2 plus -2. That's -4. 5 and 9, 4 and 3. Okay? So now you multiply everybody by 4. So we have 36, we have 28, we have 32, we have -16, 4 times 14, 56, and 28. Voila. I hope this helps.